Sequences and series is what we're going to be talking about today. So you're going to not so much learn because you've done this before, more like refresh your memory of how to determine whether a sequence is geometric, how to find sums, and also how to write formulas. Okay? So that's what we're doing today. So on your foldable, we'll start with the geometric sequences, a geometric sequence, and then we'll move on to the series from there. Okay? So definitely make sure that you're listening. You don't have to copy down exactly everything that's on the board. Just make sure that you're listening. Okay? So, when something's geometric, that means you are multiplying the previous term by r. It's called a common ratio. R, common ratio, D, common difference. Okay? Sometimes they could just say find r. You need to recognize that from there it is a geometric sequence. That it is a geometric sequence. To find your common ratio, what does u sub n plus 1 represent?
The first term. Oh,
What does u sub n plus 1 represent? Not the term before, the term after a term, and u sub n represents
the last term.
the term before. Okay?
Because you'd have to divide it because with geometric it's multiplication, dividing, adding, and subtracting.
Exactly. So with geometric ratio, you're multiplying the previous term by a common ratio. How you find it, you divide, say for example, the second term by the first term, third term by the second term, fourth term by the third term, so on and so forth. Yes. What does u sub n represent?
The term before the term in front of.
Okay, it represents the nth term. Yeah, so if n was 3, then u sub n would be u sub 3, the third term. So then u sub n plus 1 would be what? The fourth term. So to find your common ratio, you could do your fourth term divided by your third term. Okay? The term after, the term you're on, divided by the term that you're on. Okay? That's what that n plus 1 means. That's in a subscript with the n. That's in the subscript. And then you can also do the third term divided by the second term, the second term divided by the first term, so on and so forth to get your common ratio. Your general formula, which is in your reference booklet, this is also known as your explicit formula for a geometric sequence, is u sub n equals u sub 1 times r to the n minus 1. These two things are being multiplied together, the first term and the common ratio, but only the ratio is raised to that particular power. What does u sub 1 represent? The first term hasn't changed. What does n represent?
Number of terms.
Number of terms, that has not changed. U sub n,
The term you're trying to find.
term you're trying to find, the nth term, and of course r is our common ratio. Okay? So, when you open up that first little flap, you'll see this here. It says consider the sequence 2, 4, 8, or 8, 4, 2, 1, so on and so forth. Show that the sequence is geometric. How would I show that?
4 divided by 8, 2 divided by 4, and 1 divided by 8.
And every single one of these should be equal to each other. Aren't they all 1/2?
Yes.
Okay, very good. That is how you show. Okay, show that the comparison between the following term and the previous term is the exact same. Then we have to find the general term for u sub n. This one's a little bit easier because we really don't have to simplify as much as we would for an arithmetic. Okay, what's our first term?
8.
Then it says r. What's our common ratio?
1/2.
And that's being raised to the
N minus 1.
n minus 1 power, and that's it. No simplifying needed or anything like that. Again, the ratio is the only thing that the n minus 1 is applying to. which means that I would not multiply 8 and 1/2 and say this is 4 to the n minus 1. I cannot, that's incorrect, okay? Your laws of exponents, whatever the exponent is applied to is what is being raised to that particular power, okay? Then it says hence, which means using what you just found, find your 12th term. So 12 will be what?
N.
So u sub 12. So 12 minus 1. So then that'll be 11. So at this point in time, unless you know what 1/2 is to the 11th power, I suggest you use your calculator, plug that in, multiply by 8. And of course, I'm always going to opt for the fraction answer over the decimal. Because raise your hand if you have never gotten an r minus 1 on your paper. Exactly. What does that r minus 1 mean when you see it on a test? Y'all never seen this before on your test? Rounding error. And that's where you lose your point. So why not put in the fraction, which is the exact form, versus try to round that decimal? Okay?
1/20, 256.
256. Like that? Perfect. Someone up, yes?
Yes.
Like math fractions and
Enter again. Okay? Let's take it up a notch. K minus 1, 2k, and 21 minus k are consecutive terms in a geometric sequence. Find k. Very similar to one from your arithmetic homework. Using a similar process, since this is geometric, how could we set this up to find k? 2k divided by k minus 1?
Yes. Equals 21 minus k divided by 2.
Very good. You would have to basically determine what the common ratio is, set up an equation. Your second term divided by your first term should equal what you get when you do your third term divided by your second term. Okay? We did that with the arithmetic one. It was the second term minus the first. It was equal to the third minus the second. Similar process, except this time it's geometric, so we divide. Okay?
Can you cancel out the 2k?
I cannot cancel out 2k's because they're equal to each other. If they were multiplied, yes. But since they're equal to each other, how do I solve this proportion?
Cross multiply.
Cross multiply. So what's 2k times 2k?
4k second.
And actually, I'm just going to go ahead and write it out because I don't want anyone to lose. And then I multiply the other one the other way, right? Okay. So 2k times 2k is 4k squared. Very good. What am I going to have to do to the other side?
4.
So that's going to be 21k minus k squared minus 21
Plus k.
plus k. How do I solve this? Second combined terms. How do I solve this?
Subtract the 4k squared, and then it's going to become a quadratic.
How do I solve this?
we have to reset it up because your B term there is actually supposed to be your A term.
Okay.
Because it's squared.
Okay.
And then once you have it rewritten like that, you just plug it into the quadratic formula.
I could plug it into the quadratic formula. I could. I could also what? I could also factor. I could also graph it. Either way, I have options to find the value of k. I'll let you choose how you want to go from here of how you're going to get that value of k. When I rearranged, I forgot to add the square back, so y'all don't forget about it was squared. If I want to solve this graphing it, I want to plug 0 into what? y1, and then the function into y2, okay? So there is a spot where it says calculator things to remember. If you don't remember some of this, then you definitely want to make sure that you put some of these steps in there. But when you go to y equals, and this is how you can solve any equation. You guys are allowed to use your calculator the entire time. So if you ever want to solve an equation, it doesn't have to be quadratic. It could be linear. It could be cubic. It could be exponential. Doesn't matter the function. You plug the right side into one of y1, y2, and then plug the other side into the other one. So 0 into y1, negative 5x squared. Because we can't plug in k, we have to actually use, x. We just have to remember that x represents k. And then we graph it. And we're trying to see where the two, what? Intersect. I always go back to a standard window. So zoom 6 always takes me back to a standard window because I use this thing for so many different things and I want to make sure that I'm always starting back from scratch. There's my quadratic. Actually, I'm good now. So if I want to find this intersection point right here, the one that's on the left, I go where?
Nice.
Second trace. It takes me to my options. I want option number 5, and I want to find the intersection that's to the left. So I want to move the cursor closer to the left intersection point. And once I'm there, how many times? 3. The first time registers it for the first curve, the blue curve. The second time registers it for the red curve. And the third time, the calculator is going to do all the work and give you the answer of 1.4, which is 7 divided by 5. To find the other intersection point, I have to what?
Can you read that?
To find the other intersection point, I have to what? What do I have to do?
And trace closer to, or put that little cursor thing close to the other one. And then.
Enter 3 times.
It didn't work. Why didn't it work?
What happened?
I did exactly what they said. I moved the cursor closer to the intersection point. I clicked enter 3 times, but it didn't work.
Did you do second trace?
They didn't tell me to do second trace.
Oh, we'll do second trace.
You gotta do it again. That's what I was trying to get y'all to say. You gotta do second trace. You gotta go back to option 5, move the cursor closer at that point. Move. Thank you. All right, and then enter 3 times.
Yes.
Now I get the other one. So then k is equal to 3. All right?
Will it still work if it's not exactly on the line?
When you use second trace, yes. Because the thing is, as long as the cursor is close enough to the intersection point, then it will find it. It doesn't have to be spot on, okay? As long as it's closer to that intersection point than the other one, it will find that one. Questions on this? Remember, anything in that calculator you need to know section, put whatever you need to remember. All right? Open it up a little, open up again. Do you have this one?
Yeah.
Okay, so geometric sequence has u sub 2 equals negative 6 and u sub 5 equals 132. We want to find this general term, aka u sub n. So to do this, I need my first term, my common ratio, and that's it. But I have 2 terms that are not side by side. Yes?
Would you need to make U2 become U1 and then U5 would become U4?
That is one way that we can do it. We can definitely make. So we're going to make U1 negative 6. And then that means that U5 is going to be U4. And then we'll have 162 here. Then what could I do?
Plug that into, I don't know.
So if I temporarily make these what they are, I can use
We could
this information now.
find your common ratio.
I can find my common ratio. Because if I use 162 as u sub 4 temporarily,
Yes.
then I can plug in 162. I can plug in -6 for U1, and I can use this to find my R.
Yes.
How do I solve?
Divide by -6. And then find the cube root of whatever 162 divided by -16.
What is 162 divided by -6? -27. So then I would need to take the cube root of -27, and I can take cube roots of negative numbers. What number times itself 3 times gives you -27?
-3.
If it were something that wasn't an easy number like this, okay? In your calculator, on my home screen, I would go to, I feel like I've talked to you about this.
Yes.
Where? Where would I go? I would go to math, option 4, which is the cube root, and then I would type in the number.
And then the one below there allows you to put it to any root.
Correct. And then the one below it, let's say it wasn't to the 3rd power, let's say it was to the 6th power. If I went to option 5, then I can type in 6, and then I can do whatever the number is. Okay? So something else, calculator, to remember. All right? Now that I have my common ratio, I'm almost done. I just got to now find my first term. How do I find my first term? Huh?
I'm just gonna plug in the formula again with 162 actually being U5 this time.
So this time we're actually going to make 162 the 5th term. Take it back to what it was. 5 minus 1 is? 4. So this is 162 equals U sub 1, -3 to the 4th power. What's -3 to the 4th power?
-81.
Whoa. Which one is it?
No, 81. Yeah, I could be wrong. You're right.
There's a difference between this
You're right.
and this.
Oh yeah. No.
Gotta remember that 4 applies to that 3, then it makes it negative. You're raising -3 to the 4th power, so it should be a positive 81.
Okay. Cool.
Then how do I solve?
Divide by
So what's 162 divided by 81? 2. So now I have my general form.
So general term means first term.
No, general term means nth term, any term.
Oh.
Yeah.
Can you explain why you use U4 instead of U5 in the beginning?
Okay, so one of the ways to find any term in your sequence is if you basically temporarily make any of the terms like the first term. Okay, so basically what we did was instead of it being set up like this, 3rd, 4th, instead of it being like this, we made it so that -6 was the first term. There was 2 terms in between and did this. So instead of being the 2nd term, we temporarily made the first term, we pushed it up.
Okay.
And then, of course, that adjusted this to become the 4th term instead of the 5th term. That's one way to do it. It's the same thing that you could do with arithmetic as well. Okay? Another way that you could do this, though, is since without adjusting anything, okay? Very similar. You can take the term that's furthest in the sequence, which is our 5th term, okay? Not the largest one, the one that's further down the sequence. We can divide it by the earlier one, and then we can set it equal to R raised to the difference of where they're placed. That works every time. You just have to remember that you put the term that's the furthest down the sequence on top and then the one that's closest on the bottom. And then you just subtract where they're placed. Instead of doing n minus 1, you just subtract their places. And then you'll end up literally exactly at this same spot of negative 27 equals r to the third. And then literally I'm back at this same, I'm literally back at this same spot right here. Okay? And now I'll do the same process for the others. But this also will help prevent maybe us misplacing this and keeping this as the fifth term, or maybe making it the third term, you know. Questions? That's how I do it.
But for n minus, like to get n, don't you?
Because we're looking for the general term. So we're not looking for a particular term in the sequence. We're looking for a formula to find any term in the sequence. Right. On your desk. All right. Back to your notes. We want to find the first term of the sequence, which exceeds 1,400. Want to find the first term of the sequence that exceeds 1,400. Now, when you see something like this, I think you do need to write in the sequence. You need to write the sequence in. Okay? Those are square roots. Your first term is 6. Your second term is 6 square root of 2. Your third term is 12. Your fourth term is 12 square root of 2. And you're looking for the first term, not like u sub 1. You're looking for the first term where the term actually exceeds u sub 1,400. So you're actually looking for what variable in your formula? You're looking for n. Okay? And it's the first one that's larger than 1,400. So I already know my first term is 6. What is my common ratio? Say again? Root 2. If you did not know or you didn't recognize that it was root 2, how could I find it? What?
6 root 2.
And what happens to the 6's?
Cast off.
There you go. Okay? So it's going to be raised to the n minus 1 power. It should equal what?
1,400.
Because that is the term you're trying to figure out. That's the nth term. So how do I solve this?
Long?
You remember how to do it?
No.
So then, how do I do this? You go to your calculator and you type what? What am I typing into my calculator?
Isn't y equals 1,400?
Y1 equals 1,400. And then Y2 is? Now be careful. If your calculator is more updated, it's going to keep the cursor underneath the radical. And you don't want to do n minus 1 or x minus 1 in the underneath the radical. So you need to press the right arrow over to get it out of the radical. Okay? Then raise it to the x minus 1 because you know we can't use n here. And actually I should have closed it off. That was my mistake. Close it. Now I adjusted it back to a standard window earlier, but I'm not going to be able to see my graph. And why is that? Because of what?
U1 is 1,400.
Because it's 1,400. I want to adjust my window so that I can see y equals 1,400. So when I go to adjust my window, what part of my window am I adjusting to see 1,400?
Y max.
My y max. And what should I adjust it to? 1,500. I think that would be good. I'm going to leave everything else how it is so I can at least see. I see my line. Let me see if the curve, there it is, coming. Turn. Turn. Okay. So, it's turning, but it's outside of my window. What do I need to adjust now? X what? My X max. Suggestions?
20.
Okay. Okay, should be turning soon. Turning. Yes. 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 And now I go where? Second trace.
And go to intersect.
Go to intersect. Now, granted, exponential and a line only intersect 1 point, so I really don't need to move it closer. But if there were more than one, I would move it closer. And then what? How many times?
3.
So, N is 16.73, blah, 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 blah. But N represents a term. So, is it 16 or 17? If you're ever unsure, plug in 16, plug in 17, see which one actually exceeds it, and the answer is 17. Please make sure you always provide that decimal beforehand, because that is 1 point of a question like this before you actually round it up. Okay? Yes. Yes. Okay? Because every bit you say 16, you can at least get that point because you had the right, you just rounded wrong. Okay? All right. Series, okay, is the addition of successive geometric terms. Okay? So remember, series is the sum. This time it's geometric. There are 2 different formulas. One formula, to be honest, they're the exact same. But one formula is u sub 1 times r to the n power minus 1. All over r minus 1. So that's one of the formulas that we have. The other one is the exact same, except this time you do 1 minus r to the n power all over 1 minus r. You'll get the same answer no matter which way you do it. It is your choice which formula you use, okay? We will still get the same answer, all right? We're going to find the sum of 2 plus 6 plus 18 plus 54, and so on and so forth for the first 12 terms, okay? Me personally, I don't know why, but I always use this one. Like, this is the one I always go to, okay? So when I do them myself, I'm always going to go to that one. You can go to the first one, it really doesn't matter. All right? I'm looking for the sum of my 12 terms. That means 12 is going to be what part of the formula? N. U1 is 2. Then I'll have 1 minus R. What is R here? 3. It's the ratio. And if you can never recognize it, remember you can always do your second term divided by your first term. Then it's going to be raised to the n power, which is 12, all over 1 minus 3. Now from here, you can just stop. You can plug it into your calculator. That's all well and good. So again, the one thing I don't want you to do is to subtract 1 minus 3 to the 12th power. Don't say this is negative 2 to the 12th power. That's not correct. Okay? So at this point, I'm going to go into my calculator, and I'm going to get that into my calculator. Get out of this, go to my home screen. Do you guys remember how to do the fraction feature? Did I show you that?
Yeah. It's like second alpha or
Second alpha. If you press alpha, y equals,
Oh, how to make a fraction, yeah.
and you go to option 1, it makes the fraction for you. Okay, maybe some other calculator things to remember. Alpha y equals option 1. I can type in exactly how it looks on my paper. 1 minus 3 to the 12th power. Ooh, not tangent. And all over 1 minus 3. This also helps me with running into the error of not putting a parenthesis around my entire denominator and getting the wrong answer. Did you guys get that?
yes.
here so that way you can see it, but it's not gonna go. Okay, so that's my answer, 531,440. That is exact. That is the exact sum. I would not round this to 3 significant figures. Okay? It ends. That's exact.
What if it has like 2 decimals of n, but that's it?
Then that's still exact. So then I would write that out. The only time I wouldn't, where I would round is if it kept going. Okay? But if it's 2 decimal places, 1 decimal place, that's exact. Okay?
What if it's 3 decimals?
And it ends at 3, then that's fine. The only time where I would round 3 significant figures is when it's like you're hitting like 5 or 6, because then that probably implies that it keeps going. Okay? Questions? All right. A few more, and then we're done. All right?
If we, on the test, if we were to box that.
Formula for S sub n, for the first n terms. Sometimes you might have to write it out. Okay? Still simple enough. Just make sure that you put all the things in their proper places. Okay? The formula starts with what?
9.
9, the first term.
Mhm.
Keep going.
1 minus negative 1/3.
Okay. Since I do have a negative 1/3, I'm going to put that into parentheses. And then that gets raised to what?
N minus 1.
It's 3.
Oh, okay.
What's it raised to?
To n.
Just to n. Okay? Now, am I going to make this into a positive?
Yes? No.
No, because that n applies to the negative 1/3, not to the positive. So, be careful. Then on the bottom it's going to be
1 minus 3.
now this one I could write this as 4/3. But the one on the top, I couldn't because there's a power is being applied to it. Okay? And really, truly, in all my years, I've never seen it where there's a fraction still at the bottom because you don't want a fraction within a fraction. You want to continue to simplify that out some more. I've always seen it where there's a whole number at the bottom. That's what that turns into. Okay. And then from there, I can find the sum of however many terms for this particular sequence. The signs do matter. The second term was negative. The first term was positive. That's how we end up getting a negative 1/3 for the ratio. Okay. Questions? Last one. Okay, last one. A geometric sequence has first term of 5 and a common ratio of 2. The sum of the first n terms of the sequence is 635. We need to find n. Since it implies that the sum is given to us, we're going to use the sum formula. And we have all the other pieces of information, don't we? What's our first term? 5. What's our common ratio?
2.
I do not know what n is. That's what I'm looking for. All of this is over 1 minus 2. And it equals 635. Now, at this point, if you wanted to continue to simplify, you could. You could stop here and then go to your
Calculator?
to solve it. Thank you. Calculator to solve it. Okay? It's really up to you. If you want to simplify, you can. The one thing is that 1 minus 2 is what?
Negative.
So negative 1, this will make this whole fraction a negative. And actually, it would be no more fraction because it's a negative 1. Then I could also do what if I wanted to simplify?
Distribute the 5.
Can't distribute 5. Because, again, this n applies to the 2.
Divide by negative.
But I could divide by negative 5. That becomes a negative 1, 2, 7. Is that what 635 divided by 5 is? Okay. So really and truly, I can plug either one of these into my y equals and still get the same answer. It's just I would adjust my window respectively to make sure I could see everything. Okay? I can even go further if I wanted to. The last thing I could even potentially plug in would be 2 to the n for y2 and then whatever on y1. Okay? I just worry the more you simplify, the potential of making a mistake. Okay? Can we plug this in and find out what the value of n is? And this will be the last thing. Did you guys get 7?
Yes.
Very good. So we were adding first 7 terms. And that's how you find geometric series or use geometric series, sequences, etc., etc. Don't forget about this. What does that mean? Sigma notation, the sum of the to the 7th term of the explicit formula. Okay? This is the explicit formula for this particular geometric sequence, the first term times the common ratio to the n minus 1. And since I knew that that was 7, 1 to the 7th term. Okay? Don't forget about that as well.